For decades, humans have been tearing apart the Earth's interior for a drop of energy we call oil. We were told these reserves would run out and the world would be plunged into darkness. But what if we've been looking in the wrong place all along? What if the largest gas station in our solar system is millions of kilometers above our heads, where a giant moon holds a hydrocarbon ocean far more abundant than all of Earth's reserves combined? This is the story of Titan, cosmic methane, and humanity's wild dream of drilling into space to save civilization. We often think of outer space as empty, cold, and void. However, that perception changed completely when our satellites reached Titan, Saturn's largest moon. Titan is no ordinary space rock. It's a cosmic anomaly. Imagine a place where, instead of raining water, it's liquid methane and ethane. On Titan's surface, vast lakes and oceans are filled not with blue water, but with chemicals remarkably similar to the main components of our natural gas and petroleum. Scientists were astonished to discover that Titan's hydrocarbon reserves are estimated to be tens, even hundreds of times greater than all the oil and gas ever found on Earth combined. This isn't just speculative theory. Using advanced radar technology and satellites that penetrate Titan's thick atmosphere, we've mapped these methane oceans. We've seen the light reflecting off these oil lakes. But the question is, how did these chemicals get there without ancient fossils? On Earth, we know oil originates from the remains of living things millions of years ago. But on Titan, this oil is biogenic, meaning it was formed through purely chemical processes dating back to the early days of the solar system. This proves one thing: the universe is a giant chemical factory, not stingy with its energy production. We just need to know how to access it. The challenge is no longer, is there energy there? But how can we survive in a place where temperatures are cold enough to freeze the oxygen we breathe? Knowing about the existence of black gold in space is one thing, but bringing it home is another matter entirely. Currently, the cost of launching a kilogram of cargo into space is prohibitively expensive. If we tried to bring a gallon of methane back from Titan to Earth, it would probably cost enough to buy a skyscraper. Retrieving oil from space currently sounds like an unreasonable amount of money to burn. However, visionaries don't see space oil as something to bring home. They see it as a refueling station along the way. If humans one day want to colonize other planets or travel to neighboring star systems, we can't bring all the fuel from Earth because it's too heavy. We need refueling stations out there, and moons like Titan or the ice giants are perfect parking spots. The chemicals there could be processed into rocket fuel, plastics for building colonies, and even power plants in space. On the other hand, while we gaze at the stars, we must also confront a harsh reality on Earth. Conventional fossil fuel extraction has left a significant scar on our atmosphere in the form of greenhouse gas emissions. This is where carbon capture technology becomes crucial. Instead of just dreaming about space methane, our engineers are now developing ways to capture the exhaust gas and store it back underground, or convert it into useful products. Energy sovereignty isn't just about finding new wells deeper under the ocean, but about using our intelligence to manage what we already have more efficiently. The discovery of potential oil in space should serve as a reminder. Energy is abundant in the universe, but our ability to maintain a habitable environment is a finite resource. Perhaps one day, our grandchildren will look up at the sky and know that the energy that powers their vehicles comes from the light of Saturn. But until that day comes, our greatest mission is to ensure that in our search for energy beyond, we don't let our own home planet fall apart.